Okay, this is a discussion about coordinate systems for exam number 2. We've talked a little bit about these coordinate systems, and we've also discussed telescopes and their parameters. So what you want to do is have homework number 5, I think it is. Is that what it is? Homework number 5, yep. And also your textbook, Practical Astronomy with your calculator. We'll be going through these sections that are kind of short within this textbook right here. The first thing it talks about are what are the names of the different coordinate systems that are used on spheres. So there's one for the Earth sphere called Geographical. You got the horizontal, which is the sky dome. You got the equatorial, which is on the celestial sphere. And the ecliptic coordinate system is also on the celestial sphere. There's another one, the galactic, and it's also residing on the celestial sphere, but it has a different origin and kind of equatorial region from which you measure. So looking at the first one, as you look at homework number 5, the top table, the geographical coordinate system has one of the coordinates called latitude. We're going to use phi for that. And this is basically the angle how far up. And the reference for that is the equator. So you measure above or below the equator. So how far up is the latitude, and how far around that equator is the longitude. And we're going to use capital L within this textbook. The reference for how far around is the prime meridian. Remember that, Greenwich, England defined the prime meridian. And so for the how far around reference for longitude, that's going to be your prime meridian. Similarly, you have a coordinate system which is on the sky dome. In section 17 here, you have the little a and big A that we're already familiar with. And basically the little a is how far up, and how far up from the horizon in particular. So the horizon is our reference in that case. The how far around to the horizon is called the azimuth, and that is basically using a reference of the north point. So you start directly due north and you measure it eastward to measure the angle capital A, and that will go from 0 to 360 degrees around. The ecliptic system is one we're a little bit familiar with, because it's basically the numbers that you find along that ecliptic on the star charts 2 and 3. If you measure the angle above or below that ecliptic, you get the beta. Now that one's not really labeled on the star chart, but the other one, the lambda, the so-called ecliptic longitude, or the so-called heliocentric planetary longitude. Basically, this is helping you find planets. If you know the lambda for a planet, you can figure out where it is on the star chart. So the how far up reference for this is simply the ecliptic, and the how far around the ecliptic reference is going to be the vernal equinox. So that's where you start measuring lambda. You'll notice that it's 0 degrees right there, and as you go up toward the summer solstice, you'll see that it's 90 degrees there, and then it goes to 180 at the autumnal equinox, and then 270 at the winter solstice. So this was also measured eastward. So just look at those tiny numbers along that sine wave on star chart 2 and 3 to figure out where lambda is for a given star, or in most cases it's a planet. So it's labeled along the ecliptic of your star charts. The obliquity epsilon is an angular measurement, and it's the angular measurement between the ecliptic, that sine wave, and the celestial equator, that's the horizontal line on star charts 2 and 3, going through the middle. And that angle between those two circles on the celestial sphere is 23.5 degrees. So the ecliptic is inclined with respect to the celestial equator 23.5 degrees because the Earth is also inclined with respect to its axis by that same amount. Another coordinate system in section 20 is called the galactic system. We use B for this one, measured in degrees. It's the angle of a star above the galactic plane. So if a star is directly in the middle of the Milky Way, disk there, then it's going to have a B of 0 degrees. You have a similar kind of coordinate that's measured along the galactic plane, this time lowercase l, and it's the angle around the galactic plane, and the reference for that is just going to be the galactic center, where that supermassive black hole is. We've already talked about the equatorial system. In fact, we talked about a telescope mount, which was the equatorial system. That's in section 18 of Practical Astronomy with your calculator. We're already familiar with delta, the declination, alpha, the right ascension, and now we have a new measurement, and it's called hour angle. That's measured in hours of right ascension. And basically, it's the difference between the right ascension of your meridian and the right ascension of the object. Simply put, you can look at the figure in your textbook. You can see that if you look toward the south from the observatory and see the glow of Nacogdoches and Walmart right here, if you measure 58 degrees above here, that's where the celestial equator is, going from left to right. You might remember Leo is over this direction and Pegasus is over this direction, like so. I know this is 58 because this is the latitude of my location. That's 32, so 90 minus this is 58 right there. But the coordinate system I want to bring your attention to is the hour angle, and that's the capital H. It's measured toward the right relative to that celestial equator. So the celestial equator basically is a line going north and, the celestial meridian. That celestial meridian is going north to south. We measure from the right of that over, that's capital H, your hour angle. And then measuring up from the celestial equator to where the star is, that's declination. In a similar way, right ascension alpha is measured with respect to that gamma-looking thing over there, which is the symbol for the vernal equinox. So that's the ram's head, or the first point in Aries, also called the vernal equinox. And you measure toward the left from there to get right ascension. But if you're looking for hour angle, let me go back to where that was. Looking for hour angle, you measure to the right of the celestial meridian. All right, so to convert between alpha and H, you can see that they're basically connected by the right ascension of your meridian. The right ascension of your meridian is the same, the LST is the right ascension of your meridian, and you'll find that on your star chart. So here's the equation that we'll use for that part right there. All right, I'll return in the next video.